Ladies and gentlemen, welcome to section 10.2, Simplifying Radical Expressions, part 2. Yesterday we learned how to take perfect squares out of numbers. Please remember that these blue numbers are the perfect squares that we are going to be working with today. So let's jump in right into number 1. Now we have the square root of a fraction. Before it was whole numbers, but now we have a square root of a fraction. All this means is that we can take the square root to the top and to the bottom. So it's going to be the square root of 27 and the square root of 4. What we're going to do now is just simplify both the top and the bottom. Well, what's a perfect square that goes into 27? Is 27 on the list? No. Is there any number that goes into 27? Yes, 9 goes into 27 evenly. So we can rewrite 27 as 9 times 3, and that's going to go over the square root of 4. So now the square root of 9 turns into what? The square root of 9 turns into 3, and then we still have this 3 inside the square root, and then the square root of 4 is 2. And so then we just simplified this expression. Now let's try number 2. Very first step that we want to do is to write it like this. So we have the square root of 9 over the square root of 8. Perfect. Let's keep rocking. What is the square root of 9? The square root of 9 is 3. That's awesome. Now how about the square root of 8? We have the square root of, well, what goes into 8? Does 9? No, 4 does. 4 is a perfect square. So it's going to be 4 times 2. We keep rocking with this. We can take out that 4, right? And it's going to turn into a 2. So now we have 2 square root 2 on the bottom, and that's going to go below 3. Now, the tricky part here though is, look at this square root on the bottom. We cannot have, and I repeat, we cannot have a square root on the bottom of the fraction. So what do we have to do? We have to do what is called rationalizing the denominator. We have to take whatever is in the square root. So since the square root of 2 is on the bottom, I'm going to take it times the square root of 2 on the bottom, and I'm going to take it times the square root of 2 on top, because we cannot have a square root in the bottom of a fraction. So let's keep rocking with this. Here we have 3, and then the square root of 2 on top. Now on the bottom though, we have to be careful, because what do we have on the bottom? We have 2 and then times what? The square root of, remember when we multiply these square roots, it's this 2 goes in front, and the two numbers inside the radical we multiply together to get the square root of 4. The square root of 4 turns into 2. So what do we do with this 2 and this 2? We multiply them together. So for our final answer, we'll have the top part, which is 3 square root 2 over, and then 2 times 2 to get 4. That's how we get the 4. 2 times 2 to get 4. So our final answer is right here, the 3 square root 2 all over 4. Let's try a couple more. Here, looking at 3, now the radicals are already split up for us. So what do we have to do? We just have to simplify the top and the bottom. The top stays the top, so it's still going to be the square root of 3n. The bottom, though, what can we break 8 up into? What perfect square goes into 8? That's going to be 4. So it's going to be the square root of 2 times 4. Keep going with it. The square root of 4 turns into 2. We bring along the square root of 2. That's going to go under the square root of 3n. Now what do we have to multiply out of the bottom? Since we still have a square root of 2 right here, we have to move that out of the bottom. We have to multiply it out. So I multiply both sides, or top and bottom rather, by the square root of 2. So now we come up with the square root of 6n all over 2 times the square root of 4 because I took what we have in the radicals times each other. Now the square root of 4 turns into what? It turns into 2. So it's 2 times 2. So on top we still have the square root of 6n, but on bottom we have 2 times 2, which is 4. So our simplified answer is right here. Now number 4, now we also have a variable in the bottom. Does that change anything? It does not. We still want to simplify. So let's still see what we can simplify. Here we go. We have the square root of 6 on top because we cannot touch that. Well, on bottom we have the square root of what goes into 12. What's a perfect square? It has to be a perfect square. It has to be one of these blue numbers that go into 12. Well, 9 doesn't, but 4 does. 4 goes into 12 3 times. We also have y squared. So rewriting, I take out this 4. It's going to turn into a what? It turns into a 2. Now I still have a 3 left in the square root. But what also happens to this y squared? Just like there's a 2 out in front of here, the square root of y squared turns into y. And then that all goes over the square root of 6. Now, can we have a square root on the bottom of the fraction? No, we cannot. So what do we have to multiply, top and bottom? I have to multiply by the square root of 3 because that's what's in the radical. So I'm multiplying by the square root of 3. Keep going. On top, now we have the square root of 18. And that's going to be over 2y times the square root of, and then it's going to be 9. Now, can we clean this up a little bit? What is the square root of 9? The square root of 9 is 3, so I'm going to take 2 times 3 to get what? 6y. So on the bottom, I'm going to have 6y. Now on top, I have the square root of 18. Is there a perfect square that goes into 18? Yes, there is. A perfect square is 9. So we can rewrite 18 as 9 times 2. So one more time, I can rewrite this guy. I can take this 9 out, and it turns into, I'm going to go all the way back here, it turns into a 3 square root 2 all over 6y. Now, I would accept this on the test for your answer, right? Because you did a lot of work to get up to this point. But what do we notice about the 3 and the 6? Can we take any common numbers out of the 3 and the 6? We can take out a 3, right? Because 3 goes into 6. They are both multiplying to these numbers, so it's actually going to be the square root of 2 all over 2y for our final answer. Right? And now maybe you're asking, well, why can't we touch the square root of 2? Because the square root of 2 is not actually 2. It's 1.14. If you type it into your calculator, you won't get 2. You'll get 1.14. Now trying 5. Now we have two fractions multiplied to each other. Well, what do we have to do? Treat them just like fractions and multiply them across the top and across the bottom to see what we come up with. So we come up with the square root of 12 and the square root of 20. Now once we do this part, it's the exact same as 4, exact same as 3. Start simplifying the top and bottom. Figure out what perfect squares go into 12 and 20. Well, I know the perfect square that goes into 12 is 4 times 3, and then the perfect square that goes into 20 is also 4. So it's 4 times 5. On top, when I pull the 4 out of the square root, it turns into a 2 times the square root of 3, and that's going to be over. I'm taking this 4 out. It's going to be 2 square root 5. Can I have a square root of 5 on the bottom? No, you cannot have a square root on the bottom. So I'm going to multiply both sides, or top and bottom, by the square root of 5. Rewriting it all the way over here, it is 2 times the square root of 15 all over 2 times the square root of 25. The square root of 25 turns into what? Turns into 5. So what do I have to do with the 2 and the 5? I have to multiply them together. So it's going to be 10 on the bottom. What's going to be on top? It's going to be 2 times the square root of 15. Now this square root of 15 isn't really 15, it's a decimal number. But I can simplify here. I can take a 2 out of the top and bottom to have the square root of 15 on top and 5 on the bottom. Again, I cannot simplify because that square root of 15 is actually a decimal number. Let's try a couple more. Now we don't have it attached through multiplication. We actually have it attached through addition. When we have this, we have to multiply by something special. We have to actually multiply by the exact same thing, but we have to switch. Switch the sign. Switch the sign. Switch the sign. Please switch the sign. So we multiply by 4 minus 5 on top and bottom. Multiplying by the same thing, just switching the sign. Now we just multiply everything out. Take this square root of 2 times here and there. So we come up with 4 times the square root of 2 minus the square root of 10. Now, with the tricky part, it looks like a lot, but watch what it turns into in the end. So it's 4 times 4 to get 16. 4 times the negative square root of 5, so it's 4. Negative 4 times the square root of 5. I'm going to extend this a little bit farther. Now it's the square root of 5 times a positive 4, so it's going to be plus 4 square root 5. And then we have the square root of 5 times the square root of 5. That's going to give me a negative square root of 25. Can we clean any of this up? Yes, we can. The square root of 25 turns into 5. Now, if we look in the middle, we have a negative square root of, or negative 4 square root 5 and a positive 4 square root 5. So those cancel out. On top, we're going to be left with 4 times the square root of 2 minus the square root of 10. That's going to be over 16 minus 5. 16 minus 5. Keep rocking, cleaning things up one more time. For our grand finale, we have 4 square root 2 minus square root 10, and that's going to go over 11, and that is our simplified answer. 7, let's try one more. Now, we have a square root here, or square root on top, but that does not change anything. We are only concerned about the bottom. What do I have to multiply by? I have to multiply by the exact same thing, but I have to change the sign in the middle. So now I'm going to multiply by 2 plus the square root of 2. This thing is all 1, right? So I have to multiply the numbers times the numbers, the square roots times the square roots. So it's going to be 8 square root 3 plus 4 square root 6. That's going to go over the top of 2 times here now. 4 plus, and then here times here. So it's going to be 2 square root 2 minus 2 square root 2. And then finally, minus the square root of 4. Can we clean this up? You bet. The square root of 4 turns into 2. This cancels out. On top, we have what? We have 8 square root 3 plus 4 square root 6. That goes over the top of 4 minus 2. Cleaning the bottom up, we have 8 square root 3 plus 4 square root 6 all over 2. Now, very last thing, if you had this answer, that would be completely fine. But look at this 8, this 4, and the 2. All outside the square roots, we can actually cancel out a 2 out of each of those numbers to be left with 4 square root 3 plus 2 square root 6 for our final answer. Notice how we always had a whole number on the bottom, right? We always had a whole number, 11 and the 2. How did we get that? Because we multiplied something called a conjugate. All it is binomials of the form, and those A, B, C, and D's are just numbers. The product of 2 conjugates is a rational number. That is very important. They will always be a rational whole number, the product of 2 conjugates. And that does it for section 10.2, Simplifying Radical Expressions, part 2. Good day.